mission.
The ispace Series 1 lunar lander is now on its way towards the moon.
Never quit lunar quest.
Hello. Welcome to the kickoff presentation of ispace's HAKUTO-R Mission 2. This event will be held in Japanese with Japanese translation of the Japanese English speakers.
Joining today's event, please access the stream on our ispace YouTube channel for simultaneous English translation, or switch the translated channel if you join us via Zoom. 私、本日のイベントの MC を務めます。
I'm Kevin Zaleski, and I will be your MC for today's event. Thank you all for joining us today. As you can see on the slide, after a few words from our CEO, Takeshi Hakamada, he will share the latest information about HAKUTO-R Mission 2, which is scheduled for 2024. After a presentation on the landers, rovers, new corporate partner announcements, and payloads that will be used in Mission 2, Mr. Hakamada will make closing remarks, followed by a Q&A session for the media. As you may be aware, ispace is a global company dedicated to lunar exploration. Our vision is to expand the human sphere of activity into space and build a sustainable world by providing reliable payload, transportation, and data services. In addition to its headquarters in Japan, ispace has two other growing offices in the United States and Luxembourg. Our first commercial lunar acceleration program will consist of two missions. Mission 1 attempted to land on the moon, and Mission 2 will land on the moon and explore the moon. Since Mission 1 was underway, preparations for Mission 2, scheduled for 2024, had already begun, including testing and assembly. In addition, ispace is rapidly developing the new Apex 1.0 lander, not only for Mission 3, scheduled for 2025, but also to deliver NASA CLIPS program payloads to lunar orbit and the lunar surface. ispace, as a member of Team Draper, is proud to be contributing to the upcoming Artemis program through Mission 3. Today, we're gathered here in front of the HAKUTO-R Mission Control Center in Nihonbashi, Tokyo, and it is from this very Mission Control Center that the lander will operate as it heads to the moon again on Mission 2. Now, I would like to start today's program. I would like to first start with a greeting from Mr. Takeshi Hakamada, CEO and founder of ispace. Please welcome Mr. Hakamada. Good morning, everyone. I am Hakamada, CEO of ispace. In September 2010, a small company with a big vision was born. The road to the Google Lunar X Prize Challenge has not been a smooth one, but with the support of our many partners, we have been able to have this opportunity to make a new presentation here today. I would like to thank you again for your support. Since the launch of Mission 1 in December 2022, our lander and operations team have accomplished amazing feats. We have successfully operated hardware, software, and payloads developed by the private sector in space for over 100 days. And we gathered a lot of experience and valuable data while facing the challenge of landing on the moon for Mission 1. In addition, the achievement of 8 out of the 10 milestones of Mission 1 will contribute significantly to the development and the preparation of Mission 2 and Mission 3 that we are currently promoting. Thank you for your patience. Our hearts have been filled with your support. ispace is taking on a new challenge. Today, I would like to share an update on our next mission, Mission 2, which I believe will increase excitement for not only ispace, but for our customers, partners, and investors as well. We decided on the name of M2 lander to reflect our commitment to our vision and our determination not to let the moon stop evolving. We have named the Series 1 lander used in Mission 2 Resilience. Resilience means being strong and able to bounce back, the quality of moving straight forward without defeat. ispace has recovered from the very end of Mission 1 and has been preparing for the next mission. And we will deliver our thoughts to the moon through this Resilience lander. Now, there are still many tasks to be done until ispace's long-term vision, the realization of a living sphere on the Earth and Moon, is realized. But we will not be afraid or give up to implement the next missions and provide continuous services. Thank you, Mr. Hakamada. Now, there's a model of the lunar landing module called Lander in this hall. And I would like to ask Mr. Hitachi, ispace's acting executive vice president of engineering, to explain the latest status of the lander. Mr. Hitachi, please. Hello, everyone. I'm Hitachi. Now, let me explain about the Resilience lander that we will be using for Mission 2. In Mission 1, the Series 1 lander was able to demonstrate and validate each system through a number of successful results. As a result of the analysis, it was determined that the reliability and performance of the hardware aspects of the system could be evaluated highly. So, Mission 2 will not change much in terms of hardware, but will continue with the design that has been demonstrated in space and on the mission. The analysis of the Mission 1 landing failure clearly identified the causes and areas for improvement. So the main focus of Mission 2 will be on reviewing and improving the verification process that has been already implemented or reflected on Mission 2 rather. That is the introduction of the validation process for the selection and confirmation of the landing site, and its linkage to and confirmation by the required software and the implementation of an appropriate reconfirmation process in the event that operational changes to landing sites are required. As for the scope of verification and demonstration, we have expanded the scope in order to improve the level of our preparedness for landing. Based on the hardware track record and process improvements, we are confident in the successful landing of the Resilience Lander on Mission 2 and believe we can safely execute soft landing and begin subsequent operations on the moon. The Resilience Lander is approximately 2.5 meters tall and wide, which is the same as Series 1 lander. It weighs approximately 340 kilograms without fuel and is highly robust for the space environment. It also has a payload capacity of about 30 kilograms and can deliver a variety of equipment to the moon. Now, I would like to explain the state of the lander that is actually launched in Mission 2 by sharing with you a video footage. Shown here is work on the propulsion system and thermal management of the Mission 2 lander underway at the facility in Germany. In the scene, the materials necessary for temperature control are attached to the lander, an essential preparation for maintaining accurate temperatures in the lander. In addition, the piping valves, the thrusters of the propulsion system have each been verified before being integrated. This is the actual thruster, a very complex structure, so AIT is carefully taking on the work of integration. We have 3 thrusters. This is the second biggest one of the 3. Also, preparations for environmental testing are also underway at the facility located at the JAXA Space Center in Tsukuba, Japan, where each part is currently being assembled. The propulsion system, the main body, and electrical systems, and the part where the customer's payloads will be mounted are each prepared. This is where the main body has just arrived. It's visually checked to see if there's no damage during transportation. And this is the upper part of the lander, where we mount computers and harnesses. It's being prepared like this. And the thruster module, a propulsion module, has been shipped to Japan, transported to Japan already, and this will be integrated onto the lander. The main thrusters and tanks will also be integrated at the same time. When the assembly is complete, environmental testing will begin, and this will be integrated and transported to the launch site eventually. Watching this makes me more excited. I feel the Mission 2 is approaching day by day. So happy to share with you this video footage. That's it from me. Thank you very much. Thank you, Mr. Hitachi.
Just one correction. Resilience lander payload is 30 kilo is the plan. Sorry for the mistake. Now, I hope you enjoyed the video. As you can see, preparation for landing lander aiming for the moon are progressing rapidly. Now I'd like to invite Mr. Hakamada again and to talk about Mission 2. Hakamada-san, please. So, as it was explained, the resilience lander will be a highly reliable model that has been optimized based on a lot of experiences and data. In Mission 1, we were able to demonstrate not only the lander itself, but our navigation capability using the lunar low energy transfer orbit. So in Mission 2, we will also aim to land on the moon in an orbit that will take several months. More details will be shared at a later date. And M2. I know you are concerned about when it is going to be launched. We always talked about it's going to be sometime in 2024. Now, things are being ready. So, today, we would like to inform you that we will be launching in the fourth quarter of 2024. That means winter of 2024. So we will provide more details about the launch at a later date, and I hope that you will join us to witness the launch and landing of Mission 2. Thank you very much. And thank you, Hakamada-san. So on this mission, we will be taking what we call payload or goods from the various customers with us. One of them will be a major feature of the Mission 2. It's a micro rover developed in-house. And I would like to invite Julian Ramas from ispace Europe, who is a CEO.
My name is Julien Lamamy. I'm the CEO for ispace Europe. We're based in Luxembourg, 30 very talented professionals, 20 engineers currently working on developing lunar rovers for future ispace customers.
はい、ありがとうございます。こんにちは。私はルクセンブルグにある ispace ユーロップの CEO ジュリアン・ラマミーと申します。私たちのチームは30人以上の非常に優秀なプロフェッショナルで構成されておりまして、20人のエンジニアが ispace のお客様のために月探査機の開発に取り組んでおります。
So today, on behalf of ispace Europe, I'm very excited, very proud to be able to introduce to you the micro rover, which will fly on board the ispace Mission 2.
本日は ispace ヨーロッパを代表いたしまして来たるべきミッション2で飛行するマイクロローバーをここで紹介できることを大変嬉しくまた誇りに思っています。
It's time to reveal the final design. Behold the micro rover.
はい、ispace マイクロローバーの最終デザインを公開するときが参りました。
さあ、袴田さん、ジュリアンさん、準備はいかがでしょうか。メディアの皆様、準備大丈夫でしょうか。
Are you ready? And cameras, are you ready to go? So 3, 2, 1.
As I mentioned, is developed in Luxembourg by our engineers with the support of the Luxembourg Space Agency and the European Space Agency.
こちらの ispace マイクロローバーなんですけれども、私どものエンジニアが開発をさせていただいたんですが、同時にですね、ルクセンブルクの宇宙庁、そして欧州宇宙機関の支援を受けて、開発製造されました。
As you can see, it's a very beautiful machine. When going to the moon, every gram counts. So we spent extra effort to make this rover as small as possible, as light as possible. And yet you can see that it's only 26 centimeters tall, about 54 centimeters long, and weighs only 5 kilograms.
ご覧のように非常に美しいマシンですけれども、月へ行くときというのは1グラム1グラムが非常に大切になってくるということで、マイクロローバーはできるだけ小さく軽くいたしました。高さが26センチ、長さが54センチ、重さは5キロになっています。
Despite being small, despite being very cute, it's also very robust. It's equipped with electronics that can survive the space environment. It has its own cameras to explore the environment, and its own communication systems to talk with the resilience lander, which then relays communication to the operators at the Mission Control Center on Earth.
非常に小さくて可愛らしいんですけれども、非常に頑丈でもあります。宇宙仕様の電子機器や地形を観察するためのカメラ、そしてレジリエンスランダーと会話するための通信システムを備えており、レジリエンスランダーは地球のミッションコントロールセンターとの間でコマンダやデータを中継することになります。
After the resilience lander lands on the moon, it will deploy the micro rover, which will then start exploring the surrounding areas of the landing site.
レジリエンスランダーが月面に着陸した後にマイクロローバーが月面に展開されて、そして着陸地点の周辺の探査を開始します。
One of the important objectives of the micro rover on the mission 2 is to fulfill a contract that we, iSpace Europe, have with NASA. Under this contract, we need to collect the lunar soil, called regolith, and then transfer the ownership of this regolith to NASA. And we will do this under a law on space resources that was passed by Luxembourg in 2017.
このマイクロローバーなんですけれども、もう一つのミッションとしては、私たち ispace ヨーロッパが NASA と結んでいる契約を履行することです。この契約に基づきまして、探査機を使ってレゴリスと呼ばれる月の土を採取いたします。このレゴリスの所有権を NASA に譲渡するということが計画されています。我々はこの2017年にルクセンブルクで可決された宇宙資源に関する法律に基づいて、こういった活動を行うことになります。
So this regolith activity with NASA is the reason why you see a scoop on the rover. This scoop will be used to collect the regolith and take images.
この契約を履行する目的のためにマイクロローバーにはスコップが装備されています。月のレゴリスを採取して画像化することができます。
So currently, the qualification model of the rover is undergoing space environment testing, and we look forward to very soon providing more updates. Until then, please stay tuned.
現在この探査機の認定モデルは宇宙環境の試験中でございます。その進捗状況についても近日中に最新情報をお届けできるかと思いますので、ぜひご期待ください。
ジュリエンさん、ありがとうございます。本当にかっこいいローバーですね。
Thank you, Julian. It's a nice looking rover. And some of you may have noticed we have a new company joining HAKUTO-R as a corporate partner. So I'd like to introduce our new corporate partner, EPROC. Ms. Bargal from EPROC will be giving us a brief explanation. Ms. Bargal, please tell us about your company's technology and its contribution to micro rover.
Yes, hello. My name is Miriam Bergvall, and I'm the Global Manager for Acquisitions and Partnerships at EPROC.
はい、皆さんこんにちは。私、ミリアム・ベルクワールと申します。エピロックで MA とパートナーシップのグローバルマネージャーを務めております。
EPROC is a Swedish company which design, develop, and manufacture mining and infrastructure equipment. And in addition to that, we also provide solutions for automation, digitalization, and electrification.
エピロックはスウェーデンの企業で工業およびインフラ整備の設計、開発、製造を行っております。さらに自動化、デジタル化、電化のソリューションも提供しております。
Our head office is based in Stockholm, in Sweden. EPROC is a global company, and we have customers in 150 countries. We are more than 18,000 people working in EPROC, and we have a yearly revenue of 5 billion euros.
本社はスウェーデンのストックホルムにありまして、エピロックは150カ国に顧客を抱えておりますグローバル企業です。従業員数は1万8000人以上、年間売上は50億ユーロです。
EPROC has a long history. It was founded 150 years ago, and it's the oldest in the industry. With our strong focus on R&D, and proven track of past innovations, we are well positioned as a strong partner when it comes to enabling productivity and sustainability on the surface, underground, and now also in space.
エピロクの歴史は長く、150年前に設立されている業界でも最も古い企業です。R&D に重点を置き、過去のイノベーションの実績により、地表、地下、そして現在では宇宙での生産性といったところでも、持続可能性や生産性をしっかりと可能に実現する強力なパートナーとしての地位を確立しています。
Recently, Epiroc signed the HAKUTO-R corporate partnership agreement with ispace. This agreement involves us working together on the M2 mission on activities related to ispace contract with NASA for the collection of lunar regolith and to transfer of ownership to NASA.
エピロックは最近 ispace と HAKUTO-R の企業パートナーシップ契約を締結いたしました。この協定は ispace が NASA と締結した月のレゴリス採取と NASA への所有権譲渡に関する契約に基づく活動、M2 ミッションでM2 ミッションにおいて私たちが協力することも含まれております。
Our engineering department has, in close collaboration with engineers at ispace, designed and developed a regolith collection system, or a scoop, the one you can see here. And this scoop will be mounted on a micro rover and will be operated by ispace during the M2 mission to collect the lunar regolith.
エンジニアリング部門が ispace のエンジニアと緊密に協力しまして M2 ミッションで ispace が運用する月のレゴリスを収集されるためのマイクロローバーに搭載されるレゴリス収集システムスコップですね、先ほどの画像の中にもありましたけれども、こちらを設計開発いたしました。
In addition to the actual scoop, Epiroc has also designed the electronics and software to control the payload.
また実際のスコップに加えてエピロックではペイロードを制御する電子機器やソフトウェアも設計しております。
Earlier this year, we also signed a long-term collaboration agreement with ispace, and this agreement will involve Epiroc contributing with technology and solutions for existing and future potential commercial moon missions.
また今年の初めにはispaceとの長期的な協力協定を結び、既存およびそして将来の商業的月ミッションの可能性に向けた技術やソリューションの分野で貢献していく予定です。
At Epiroc, we are very excited to collaborate with ispace to develop and provide technology and solutions together and to begin exploring the moon's surface in a sustainable way. And we look forward to our contribution and collaboration to make the mission successful.
私たちは ispace と共用できることを本当にワクワクしています。持続可能な方法で月面探査を開始するための技術とソリューションを共に開発し提供することで、そしてミッションを成功させるための継続的な協力関係を楽しみながら共に一緒に築いていきたいと思っています。
ペルクワヤさん、Thank you so much for your explanations. ありがとうございます。また引き続きHAKUTO-Rのパートナーの皆様から
With the continued support of HAKUTO-R partners, ispace will continue to take on the challenge of realizing HAKUTO-R's Mission 2. In addition to Epiroc, as a corporate partner, the following companies have also joined: Chiyoda Corporation, Namco Bandai Research Inc., the University of Adelaide, and Kurita Water Industry Limited as new supporting companies for HAKUTO-R. Many companies share our vision and are also supporting us in this mission too. Next, ispace's CEO, Mr. Hakamada, will explain about the payloads to be carried on Mission 2. Mr. Hakamada, please. Through Mission 2, ispace is not only aiming to land on the moon and explore the moon. Therefore, we would like to emphasize landing and beyond as the goal of M2, landing and beyond. Mission 2 will explore the moon's surface with ispace's new micro rover. This will enable activities that are critical to advancing the creation of the cislunar economy. Lunar development begins with the exploration of the lunar surface and the demonstration of technologies on the lunar surface. We are also planning technology demonstrations and equipment for our payload customers and are aiming for groundbreaking activities. In addition to the micro rover developed in-house at Mission 2, we plan to deliver our next customer payloads to the moon. To begin with, Takasago Thermal Engineering Corporation plans to develop a lunar water electrolyzer and conduct experiments on the production of hydrogen and oxygen on the moon's surface. Such resources are expected to support life and activities on the moon in the future, not only for air and drinking water, but also for fuel production. The next payload is experimental equipment from National Central University in Taiwan. This equipment is mounted on the top panel of the lander and will measure radiation levels and radiation-induced bit errors in space and on the moon. This payload will also be the first payload from Taiwan to go beyond low Earth orbit. A self-contained module equipped with algae culture observation capabilities of Euglena Company will also be carried on the lander as a payload. This is expected to be a lunar environment experiment for future food production in space. Finally, as part of the Gundam Open Innovation Project of Bandai Namco Research Inc., it will be equipped with a special alloy plate based on the design of the Space Century Charter, a stone monument that appears in the Mobile Suit Gundam UC anime. These will be the payloads on Mission 2. ispace is not a one-off mission company. Foldscape preparations for Mission 2 and then Mission 3 have already begun and are under development, while Mission 1 is still underway. To achieve this, we will not only develop the project, but also finance it in parallel to ensure its long-term sustainability in the future. The development of the new lander for ispace's Mission 6, which is further along than the next Mission 2 and 3, was also selected as a project eligible for the SBIR subsidy recently announced by the Japanese government, securing a portion of the costs necessary for its development and mission implementation. Today, we introduced Mission 2, HAKUTO-R, our partners who are supporting us in this challenge, and our payloads. It is only with your warm support that we are able to take on this challenge. With the help of all our supporters, ispace employees, and their families for supporting them, we will continue to take on the challenge of going to the moon. We would also like to reiterate that ispace is a resilient organization. And although we did not land on the moon in Mission 1, we will use our rich experience and data gained through that experience to improve our Mission 2 resilience lander to land and go beyond landing and beyond. Thank you. Never quit the lunar quest. Thank you, Mr. Hakamada. Today's event comes to a close here. Thank you to everyone who participated at the event and online. We will be ending the YouTube streaming of the event and will continue the Q&A session for the media on Zoom, which will be announced separately. Thank you very much for watching the event on YouTube.